everybody, and continuing on the critical topic of security for developers. Our next talk is how to secure your software supply chain, and you're going to hear this from a strategic cloud engineer who comes from the beautiful German side of Lake Constance. Please welcome Christoph Grotz.
So, good afternoon. My name is Christoph Grotz. Emily already announced me. And today I would like to speak to you about how you can secure your software supply chain and what's the things you might want to look out for. So, before we dive into the details, I'd like to give you a quick overview of software supply chain security and why it's such an important topic these days. Your applications normally consist of source code that your organizations create and dependencies that you consume from third parties. You probably have a build process that takes the source codes and those dependencies and creates packaged software out of that. These packages, you either run them in your organization or maybe other parties consume these packages as dependencies from you. The dependencies that you are consuming are provided to you that might be open source packages or that might be commercial products from other contributors. So these contributors, they have their own software development lifecycle with their own security processes in mind. This, as you can see, constitutes a software supply chain, where you can be a consumer of dependencies, where you can be a provider of dependencies, or often you're actually both. This may leave you vulnerable. We are consuming software from a wide range of sources with unknown contributors, and we don't really have the transparency into their processes. We are seeing a surge in attacks on this software supply chain. Sonatype has noted a 650% surge in supply chain attacks year on year. And Gartner is estimating that by 2025, almost half of the world's software organization will have experienced software supply chain attacks. At Google Cloud, we are observing real-world attacks on a wide range of vectors in the software development lifecycle. Most organizations are focusing on source code scanning and vulnerability scanning of the source code. But with the vectors we observe, like compromised build system, compromised package repositories, injection of compromised packages, those methods are not really up to the task. So the question is, what can you do to improve your security posture? As you have already heard in the keynote, we're happy to announce Software Delivery Shield as Google's answer to that problem. Software Delivery Shield is a holistic solution. It really tries to help you from the development all the way into the runtime. It's built on Google internal best practices like trust-based policy systems. And Software Delivery Shield is a modular approach. You can take all of the components together, or you can take individual components and integrate them with tools you are already running as part of your software processes. Software Delivery Shield supports your security advices directly in your IDE and workstations. It helps you by managing the security posture of your dependencies. It provides out-of-the-box security capabilities to your build pipelines. And it helps you with security posture management on your runtimes, like GKE and Cloud Run. And with trust-based policy system, you're able to connect all of those individual parts together. So let's start with cloud workstations. A secure software development lifecycle starts with where the developers actually develop the code. Cloud Workstation provides fully managed development environments in the cloud, supporting popular IDEs like VS Code and IntelliJ, and Java JetBrains IDEs. It's designed with security in mind, with a number of features around that. Administrators can configure private ingress and private egress. They can configure VPC service controls to prevent data exfiltrations. And forced image updates of the workstations make sure that the developers are always working on the latest version of the development environment. With Source Protect, we shift dependency vulnerability and license awareness left directly into the IDE of the developer. This gives the developer much faster feedback, increasing productivity when it comes to closing security gaps. This obviously also works with cloud workstations. We improved artifact registry with a long list of features focused around security. The goal is to provide insights faster, simplify dependency governance, and reducing attack vectors. Cloud Build now supports out-of-the-box Salsa level 3 builds. This means in addition to already providing ephemeral and isolated build environments, Cloud Build now also provides authenticated and non-falsifiable build provenance. That's very important if you need to have auditability on your builds. And, sorry, one step back. In the new Security Insights panel, I think you all seen that in the morning already in the keynote. You get now the Salsa level of your build, you get the software bomb of your build, you get vulnerability information, and you can see the build provenance information. We're going to take another look at that in the demo. On the runtime side, we get additional insights in GKE and Cloud Run. So in GKE, we now have a new feature called Security Posture Management, which continuously scans your GKE environment and gives you recommendations on how you can configure your workloads with PodSec security best practices and where you have vulnerable images and workloads running in your environment. And on Cloud Run, we also have the Security Insights panel that you already know from Cloud Build in place so that you can see the security posture of the container you're running. To tie everything together, binary authorization allows us to make our security policies actionable. So we can verify with binary authorization that each step of our security process was executed, that we have the attestations, that this image, we can trust it, we can run it on our runtimes, so GKE and Cloud Run. So next thing is we're going to take a look at how this all actually connects into the system. We're going to start with seeing how Software Delivery Shield helps us to create secure containers. We start with Cloud Workstations. We're going to see the features there. We're going to see the insights that it gives us. Then we're going to take a look at how Cloud Build helps us to build the container. We're going to take a look at container analysis for our container vulnerabilities. Then we're switching over to the runtime. We're going to check how binary authorization gives us assurance that only trusted containers are actually running in the runtimes. And we're going to take a look at security posture management and how the insights that we get from there actually then feed back right into the developer's environment to fix the problems. So, Then let's move over to the demo. And of course, I need to log in. You know, security starts on the developer machine. So that's the Cloud Workstations overview panel. You can see I already have a workstation. We're going to take a look into that in a second. In Cloud Workstation, when you want to create, as an IT administrator, create a new configuration, so developer workstations are spawned from configurations. We get a wide range of features that we configure. On the one hand side, we can make decisions on a cost basis. They're not now really security relevant, about how many workstations we want to have pre-configured already running to increase developer productivity. But we can also define things like machine types. So how big should our developer machines be? Do we need GPUs in case that we're doing AI work on those machines? We can configure shielded VMs, secure boot, and so on, what you already know from other parts of GCP. And we can define the actual developer environment, so we can select which image we want to run, so container image we want to run as a developer workstation. Here you can see that's a bigger list. So we have Code OSS, we have support for different JetBrains IDEs, or you can also configure a custom image if you want to pre-configure the developer environment with the tools that your organization needs. And we can, of course, also configure storage for those machines. Now, let's jump directly into the workstation. My workstation is already running. I can go here, and I need to reload the window. Give it a second. You can see it's rather fast. So in my Cloud Workstation that I have here, let's get rid of that. I have Java available. I should have Maven available. Yes, wonderful. And I'm working in a very standard Spring Boot project. slightly older version of Spring Boot. I'm using a new feature from Artifact Registry here. That's remote repositories. So in Artifact Registry, as you have read on one of the slides before, we now support virtual and remote repos. So here I have a cached remote repository with Maven Central, so that when you now do a Maven clean install, the dependencies are downloaded much faster. Then some version configurations and dependencies, but oh no, what's that? You can, see we have a few linter errors here, this red curly lines. Let's hover over that, and that's now source protect. So here you can see that we have security vulnerabilities direct on this dependency. Let's check the list out. There's a remote code execution in the Spring Framework version 5.3.16. But hey, my dependency is actually Spring Boot Starters Web. It gives us also dependency insight, this vulnerability insights on transitive dependencies. And I mean, I guess you all have at least once in your life called Maven install, and then it starts downloading half the internet, and maybe you're sitting there and wondering, what am I actually downloading right now? So it's really important to understand you might have just one dependency in Maven, and that one might not have security vulnerabilities, but who knows what you're downloading, and with those transitive dependencies, you can be vulnerable. And what you can also see here, that's what's quite nice, for each of these dependencies, if there is already a version that doesn't have this vulnerability anymore, where it's fixed, it gives us also the hint, okay, if you update to this minor version, for example, this CVE is gone. So my product owner wanted me to do a fix, so I'm just going to ignore that real quick, and he really wanted me to push that into production as fast as possible. So let's just make our small fix, commit the controller, and push it into our Git repo. So cloud build, in a second, hopefully, should trigger the build, and then hopefully my build goes into production. I'm going to skip a little bit in time now, because it's going to take 4 minutes to run the build, and we don't really have that much time. So that will be the outcome of what we do. So you can see Maven is packaging the project, no problem with Maven Verify and with Maven Package. We're building a container, pushing it to the Artifact Registry, but our vulnerability signer doesn't allow this, will not sign this image. So we don't get an attestation on this image, and the build breaks. That's obviously unfortunate, and maybe we should take a look at why that is. So let's go to Artifact Registry and take a look at our container image. Okay, there's the vulnerabilities tab with the scan result. Okay, so critical errors, vulnerabilities with a high impact rating, not just on the operation system level of the container, but also on the Maven dependencies, which is quite interesting. For example, here, probably on the next, no? Yeah, Spring Core, Spring Security, so all's there. Okay, but I really, really want to deploy this container. I don't want to now, what does the attestation even cause? So obviously, the good television cook that I am, I prepared the command already to deploy it. Let's just put our image in here and fire away. I guess Kubernetes will take it anyway. So let's deploy. Oh, that's binary authorization. Since the image doesn't have the proper level of trust, the signing and with that attestation from the vulnerability scanner, binary authorization doesn't allow us to run the image on GKE, which is great. So now I actually have to take care of all of the security vulnerabilities. Let's just pretend that I did and take a look at the next build where I did that. So now wonderful, the vulnerability signer is giving us green light. It's accept the Snow CVEs that it's complaining about, so we actually get the attestation for our image. And as part of the pipeline, we're triggering cloud deploy to then deploy the application onto the GKE clusters. In cloud build, on build artifacts, we can now go to security insights, where we get more information about the build artifact. So on the one hand side, we can see, okay, there still are some critical and high-level vulnerabilities that we as an organization made the decision to accept the risk. And we get our SBOM. So here we can really see, okay, what's all the dependencies that went into building this package. So we have the base layers from Docker, but we also have our Java and Maven dependencies in here. And can understand it's actually a long list of what goes into the image. And down here, the new build provenance tab, which we remember that's actually a pretty cool feature because we don't just have the SBOM, we also have how was this image built in a way that even after a lot of time we can still connect these dots. And there you can see, okay, the image was built with cloud build on those hosts. That was the entry point for the build. We can see the individual steps that were run, on which containers, what was executed, when was it run, what was the outcome of the individual steps. So really good information for us. Okay, now let's go over into the runtime side, as mentioned earlier. So we now have a secure container that we can actually run on our clusters. So in Kubernetes, we have this new security posture management feature. That's basically the dashboard that you get. And what you can see here is I have 3 clusters. Since my application has to go through our secure build process, it doesn't have a lot of vulnerabilities, so I deployed a few things which will raise concerns. We get 2 things. We have to enable that for our clusters, but we get configuration concerns. So where can we improve our Kubernetes resource definitions? And we get vulnerability concerns for the images that we have deployed. So for example, here we can see that we have a CVE for expat 248R-R0 from the Alpine image. And we have a few configuration images. Now, when you have a lot of workloads running and you maybe have more clusters, that's not helping you to drill it down. So that's where you go to the concerns tab. On concerns, we have different choices how we can analyze these concerns. We can analyze by concern type. For example, okay, this pod container is allowed to run as root concern. We have 5 workloads affected by that. Maybe that's something where we want to do more of a structured organizational approach to fix it. We can take a look at it on a namespace level, where we can get, okay, this namespace, this workload has these vulnerabilities, or on a per workload level. So for example, the simple Go app has pod container allows privilege escalation. Or, really useful, sometimes you want to start with the most critical things to invest your time wisely. The workday only has so many hours, so you have to decide what you tackle first. So maybe we start actually by the critical problem, the outdated base image. But for us to circle back, let's actually take a look at, from our demo app, at the pod container allows privilege escalation, because I think it's really useful to see we get a recommended action. So here, security posture management really gives us directly a recommendation how we can fix this problem. So we didn't configure any security context in this pod deployment. So it gives us the recommendation, if we don't need it, A, make it explicit, and B, just disable privilege escalation. So here, we just go back into our cloud runtime, cloud workstation, sorry, go into the our deployment. And so yeah, then for this container, I really don't need privilege escalation. Sorry. And just disable it. And that's how we get this continuous scanning in GKE, which informs us, and we're circling back to cloud workstations to then fix the problem. So let's wrap it up. All of the features you have seen today are available in preview. Stuff like binary authorization, actually for a long time, I think it should be at least preview. You can get started if you want to try it out yourself with our quick start tutorials. You should check out our software supply chain security website to get more information on the individual pieces and what you can do and how you can use them. And I recommend that you try listen to the other talks on Google Cloud Next on cloud workstations, GKE, NTOS, and CI/CD to get a good picture of all the individual parts that you're using. And that's it. Thank you for your attention and enjoy Cloud Next.